Welcome to this new tutorial video. Today we will be creating an NFT image on Solana, uploading an image file and metadata from our mobile device to the QuickNode IPFS service. Today we will use the repo from our previous tutorial, where we developed an app that allows us to create or import a seed phrase to log in and display the NFTs in our account, and allows us to interact with a custom NFT creation program on Solana. Today we will complete the process by adding the functionality to directly upload our NFT image and metadata from the phone to an IPFS service, in our example, the QuickNode IPFS, to then create the NFT using our custom program on Solana. Let's go to our repo Flutter NFT on-chain QN, link in the description, and copy the address. Then in VS Code we will git clone with the address we copied. We are going to create our .env file, just as we did in the previous tutorial. Our file will have these two variables, QuickNode RPC URL and QuickNode RPC WSS. In both, we will place our QuickNode RPC for the Solana DevNet, and in the second, we will change the HTTPS header to WSS. This RPC allows us to use the QuickNode NFT API service to receive NFTs from a Solana account. Now, on the home page, we will delete all the code between our mint NFT and show NFT card widgets. We delete the content of the onPressed function. We delete the create NFT function. We delete all the variables we will not use. And we change our icon in the mint NFT to an arrow icon pointing to the right. We will move all the UI of the NFT creation process to a new page. In the Pages folder, we create the file, create NFT Dart, and inside, we will create a stateful widget called create NFT page. Let's declare a Solana client like this, automatically importing the corresponding library and declaring it in the constructor. In the main.dart file, we will create the route to the create NFT page, like this, and we will declare our Solana client that we will take from the extra argument of the route as Solana client type to pass it to our widget as appropriate. On the home page, when clicking on the corresponding icon, we will simply navigate to the create NFT route with the Solana client as an extra parameter. Now in our create NFT page, we will create this scaffold with title Mint NFT, a button to navigate back to the home, and in the body, a form that will carry a scrollable column. Let's declare our auth form key like this. First, we will deploy a size box with the image we select from the phone by pressing this text button that will call the pick image function that we will create below. Let's import the image picker library in our pub spec as follows. We declare the image file of type file, importing the Dart.io library, and we create the pickImage function where we will select an image through the image picker class, importing the library of the same name. If the path obtained is not null, we instantiate the image file with a set state so that it is displayed on screen. Now we will place these three text fields with their respective validators, and we must declare a text controller for each one as follows. Further down, we will place a button with the following logic. If this NFT minted variable is false, That is, the NFT has not yet been minted. We validate the fields. We change this flag by uploading the image to true and call the upload image function. Otherwise, the button takes us back home. The text on the button is accept if the process is already complete, or mint to start the process. Let's declare all these flags that we will use to control the display of information during the process. Now, we are going to create the code to upload files to the IPFS service we will be using. In the services folder, we will create the upload to IPFS file, and there we will create the function of the same name that will receive a file and return a future of type string or null. We will need an API key from our service to upload files. On QuickNode.com, we go to Files API key and create a new one that we will copy. Then, in our .env file, we will create this variable, QuickNode API URL IPFS, and paste our API key back in our upload to IPFS file. We load the variable from the .env file, and we define the URL through which our service allows us to upload files. Now we are going to generate a name for the file we will upload, taking the final part of the file path, and we will generate a list of 8 random numbers that we will concatenate with the file name to ensure a unique name for each file we upload. We open a try-catch, define this header with our API key as shown on screen, and now we create our request. This will be a multi-part request with post method to the address of our API URL. We must import the HTTP library like so, and we will add the headers we declared to our request. In files, we will add our file through this multi-part file class from path method with the body field, which will receive the path to the file. In the key field, we will send the unique name that we have created, and in the content type field, the text string. It remains for us to send the request through the send method of the request, which we will instantiate as a response through the fromStream method of the response class, and the result we will save in the response variable. We decode the response, and we are interested in taking the CD value within the pin parameter in order to return it to whoever called the function. Remember that these parameters are specific to the QuickNode IPFS service, and you must modify them if you want to use an alternative service. Back to our Create NFT page, we will create the upload image function with which the minting process begins. First, we call the function we just created and that we must import from the upload to IPFS file, sending the image file. We save the CID that the function returns in upload image result. If this is not null, we assign it to the image URL variable, which we must create. We activate the uploaded image flags and uploading JSON through a set state, and immediately after, we call the upload JSON function that we will create. In this function, first we will create a map string dynamic data that will contain the data of the JSON file that we will build, where we will take the name, symbol, and description from the corresponding text controllers. We will build the image URL by appending the CID we obtained in the previous function to the prefix used by the QuickNode IPFS service to build the URL of the files. We will embed an empty list in attributes and collection and in the properties parameter, an empty list in creators, simplifying the implementation a bit for this tutorial. And in the files parameter, we must place the URI of the file concatenating the CID of our image to the IPFS // as shown on screen. In this way, our NFT complies with the requirements of the Metaplex standard. Now, we will create our JSON file, encoding the data map as a JSON string, and then we take the temporary directory of the device through this function, but first, we must add the Pathfinder dependency in our POOF spec. Then our file we will build it with the path to this temporary directory concatenated to the name entered by the user in the name field with the JSON extension, and then we write the encoded JSON to the file. In order to be able to call our upload to IPFS function with the JSON file. Then, if we obtained a CID and not a null result, we continue the process, saving the CID obtained in this side variable that we will declare as a string. We update the flags, JSON uploaded and minting NFT to true via a set state, and continue the process by calling the create NFT function that we will now create. Our function will call the create NFT function that we must import from the mint NFT file in the services folder. This file we created in the previous tutorial. I leave you a link in the description if you have not seen it yet. And it receives as parameters the Solana client, which is sent from the home route, the CID of the JSON that we just obtained in the previous function, and the name and symbol that we will give to our on-chain NFT, taken from the data entered by the user. We save the result in this mint NFT result variable that we must declare as a string. And we update the NFT minted flag to true via a set state. Our process is ready. We just have to display the process information on screen. Below our mint NFT button, once the uploading image flag is activated, we display a row with a progress bar and the text uploading image, while the image uploaded flag remains false. When it is updated to true, we place a green check mark with the text image uploaded. Then we do something very similar when the JSON is being uploaded with the corresponding flags and texts. And finally, when the minting NFT flag is activated, a progress bar and the text minting NFT is displayed, while the NFT minted flag remains false. When made true, we display this row with the green check mark and the transaction hash that we have saved in the mint NFT result variable. All this inside a single child scroll view to avoid overflow on the screen. Let's run our app and see how the Mint NFT tab now takes us to this page where we can select an image, enter a name symbol and description, and press Mint NFT. We see how the information we programmed is displayed on the screen, and we get the hash of our transaction correctly. If we go back to the home page, we can see our minted NFT correctly. If you've made it this far, you now know how to create a fully functional Flutter app with a login, displaying and minting NFTs on Solana using QuickNode services. Please subscribe, ask your questions, and share. See you next time.